Students, today we will study Markownikov's rule and different examples of Markownikov's rule. First of all, we will see what is Markownikov's rule. According to Markownikov's rule, when an unsymmetrical reagent is added to an unsymmetrical alkene molecule, then the negative part of the adding reagent added to that double bonded carbon atom which has least number of hydrogen atoms or no hydrogen atoms. So first of all we write the rule. When an unsymmetrical reagent is added to an unsymmetrical alkene, molecule, then the negative part of the adding reagent added to that double bonded carbon carbon atom which has least number of hydrogen atoms, or no hydrogen atoms. Least number of hydrogen atoms, right? Or no hydrogen atoms. Students, an unsymmetrical alkene molecule is that alkene in which the carbon atom, both the carbon atoms forming the double bond, have unequal number of hydrogen atoms, right? And unsymmetrical adding reagent is usually a polar molecule in which the bonded atoms, they have partial negative and partial positive charges. Let's try to understand this rule with the help of some examples. Now, example number 1. See the first example. For example, we have a molecule like CH3, CH, double bond, CH2 plus HBr. Now students, how HBr is added to this alkene molecule? Here you can notice, students, this alkene molecule is an unsymmetrical alkene. Here you can notice both the carbon atoms forming the double bond have unequal number of hydrogen atoms, right? Suppose this is carbon number 1, carbon 2, carbon 3. Carbon number 1 has 2 hydrogen atoms while carbon number 2 has just 1 hydrogen atom, right? Now HBr, it is a polar molecule. due to the difference of electronegativity between hydrogen and bromine. Since bromine is more electronegative atom, its electron pulling power is greater as compared to hydrogen atoms, right? So there is a partial negative charge on bromine and partial positive charge on hydrogen atoms. Now apply the Markownikov's rule. Now according to Markownikov's rule, hydrogen, what is the negative part of this molecule? Of course, bromine is the negative part of this molecule. So according to rule, the negative part of the adding reagent added to that double bonded carbon atoms which has least number of hydrogen. Here we can notice carbon number 2 has 1 hydrogen atoms. So according to Markownikov's rule, bromine is added to carbon number 2. Right, and hydrogen is added to carbon number 1. Hydrogen is added to carbon number 1. Right. So after the reaction, we get the molecule CH3 CH Br CH3. So in this way, this molecule is propene. This molecule is propene. After the addition of HBr, we get the molecule, a saturated molecule, that is 2-bromopropane. It is formed. This is the actual product, right? Which molecule will not form, students? If somebody added this is according to, this product is according to Markownikov's rule, right? If somebody write the product like this, CH3 CH2 CH2 Br, this is 1 2 3. This is 1-bromopropane. Now students, this product which is formed is not according to Markownikov's rule, right? So this is not the actual product. This product is not formed. This product is not formed because it is not according to Markownikov's rule. This product is formed, right? Now let's see. Here we have another example, students, to understand Markownikov's rule, right? Suppose if we have an alkene molecule like this, CH3 CH3 double bond CH2, right, student? Now this molecule is 1 2 3. This molecule is 2-methyl 1-propene. Now if we want to add HBr to this molecule, HBr. Now hydrogen bromide is a polar molecule, right? Due to the difference of the electronegativity of bromine and hydrogen. Bromine is more electronegative. It pulls the shared electron pair towards itself with greater force as compared to hydrogen. So bromine is partial negative while hydrogen is partial positive. Now students, will see what type of products are formed if we add HBr to this alkene molecule. Here you can notice this alkene molecule is unsymmetrical alkene, since both the carbon atoms forming the double bond have unequal number of hydrogen atoms, right? Carbon number 1 has 2 hydrogen atoms, while carbon number 2, it has no hydrogen atoms, right? So we will see what type of products are formed. Now the first product, if we write the first product like this way, the first product, here, if we write the first product, now if bromine is added according to Markovnikov's rule, if it will add it to this carbon, forming the double bond, has no hydrogen, right? And hydrogen goes to add it to carbon number 1. Now, after that, we get the product like CH3, bromine is added to this carbon, right? And CH3. This is 1, 2, 3. The IUPAC name of this molecule is 2-bromo 2-methyl propane. 2-bromo 2-methyl propane. Right? Now, the second possibility, what should be the product? If somebody add bromine atom to this carbon, right, then what should it be the structure of the molecule of product which is formed? CH3, CH2, CH2, Br, CH3. Right, students? We make each carbon tetravalent. Now, here a functional group is attached with carbon number 1. So, we do the numbering from this side. Since here bromine is the functional group. 1, 2, 3. The IUPAC name of this molecule is 2-bromo 2-methyl. 2-bromo 2-methyl propane. Dear students, this product will not formed because in this product addition not take place according to Markovnikov's rule. Adding reagent is not added according to Markovnikov's rule in the alkene molecule. So that's why this product will not form. It will not form. In this product, adding reagent not proceeded according to Markovnikov's rule. So, what is the actual product of this reaction? The actual product of this reaction is this product, right? That is 2-bromo 2-methyl propane. This product will formed after the reaction. I hope this is clear to you, students.